welcome to another module in this massive open online course. So, in this module, we are looking at quantization. Alright, let us continue our discussion on quantization, and this module we have already looked at uniform quantization. In this module, let us look at a different algorithm for the design of a quantizer, which is termed as a Lloyd max quantizer. Okay. So, you want to look at the Lloyd max quantizer, which is really a scheme to design the optimal quantizer. So, the Lloyd max quantizer gives what is known as the optimal quantizer. Optimal meaning it minimizes the error, quantization error. Optimal meaning it minimizes, right, it gives the lowest quantization error. Okay. So, for an optimal quantizer, now remember a uniform quantizer is a very simple quantizer which simply chooses the intervals of uniform length and then places the quantization level in the middle or the midpoint of each interval. Now, for any optimal quantizer to design a better quantizer, one has to optimally choose these different quantization intervals which are characterized by the boundaries of the intervals and of course, the level in each interval. So, we have to choose. So, for an optimal quantizer we have to choose these intervals m0, m1, m2 so on up to ml, correct. So, these are, for instance, each of these are your intervals, correct. So, we have to choose to design an optimal quantizer, we have to intelligently choose these intervals, and in each interval you have the quantization point which need not necessarily be placed in the middle, that is, it need not necessarily be placed in the middle of each level. So, I have nu 1, nu 2, for instance nu 3, so on up to, for instance, nu L. So, I have the quantization intervals, and these nu 1, nu 2, nu L are these are your quantization levels. And from the quantization intervals and the quantization levels, one can determine the quantizer, because remember the quantizer is if the sample m lies between mk and mk plus 1. So, this is equal to nu k if mk less than or equal to m less than mk plus 1. Okay. So, intervals and quantization levels, these determine the quantizer. So, to determine a better quantizer or an improved quantizer, we have to optimally choose the quantization levels and the quantization intervals and the quantization levels which minimize the quantization error. So, to design an optimal quantizer, we have to choose, or one has to choose quantization intervals and levels which minimize the one has to choose the intervals and levels which minimize the quantization error. So, how do we choose? So, the design of the quantizer is nothing but, well, you have to come up with the boundaries of the intervals m0, m1 up to ml, these are your interval boundaries. And the quantization levels. These are the quantization levels. So, you have to choose the interval boundaries and the quantization levels, alright. So, that constitutes a complete quantizer, because once you determine the interval boundaries mk plus 1, when the signal sample lies between mk and mk plus 1, you are quantizing it to nu k, alright. So, once you design, once we give the set of these, characterize the set of these boundaries, alright, the interval boundaries and the levels in each interval, quantization interval, we have completely characterized the quantizer. So, we have to optimally choose these quantities, okay. Now, how does the Lloyd max algorithm optimally design these or optimally choose these quantities? For that, we have to start with the probability density function of the signal sample m, alright. So, to start with the Lloyd max quantizer, we have to first consider f of m, or let us make it symmetric. This is your f of m, which is this is your probability density function. This is we have to start with the probability density function PDF of the signal sample m, okay. So, let us consider the signal sample is random in nature, that is m, the signal sample is random in nature. So, and it is characterized by this probability density function f m of m. And now, we have to place these intervals m0, m1, ml and the quantization levels nu 0, nu 1 up to, or nu, we have to place these levels nu 1, nu 2 up to nu l, and we will use the probability density function. So, we have to consider the probability density function of the signal sample m, alright. This is the probability density function of the signal sample m. Now, m0, m1, m2 are the interval boundaries, we already know that m0, m1, m2, these are the interval boundaries okay. Now, let us denote by the kth interval mk to mk plus 1, let us call this as the kth, interval. This is your kth interval, and the quantization level in this is nu k, okay. So, let us call this as the kth interval, or let us call mk minus 1 to mk as the kth interval, mk minus 1 to mk, mk minus 1 to mk, this is the kth interval. Nu k is the quantization level, this is the quantization level. Nu k is the quantization level in the kth interval, Okay. Now, we need, as I have already told you, we need to find both these quantization levels, quantization intervals and the quantization levels. Alright, to determine the optimal quantizer, we have to find both the quantization intervals and quantization levels. And therefore, what we are going to do is we are going to find them in an iterative fashion. So, Lloyd Max algorithms, we are going to find in an iterative fashion. Now, what do we mean by the iterative fashion? Given the intervals, we will find the optimal quantization levels. Given the optimal quantization levels, we will find the optimal quantization intervals or the quantization interval boundaries. So, our algorithm, the Lloyd Max algorithm, in summary, so what we are going to see in this Lloyd Max algorithm is basically given the quantization levels, all right, or given the intervals, we will find the levels, and given the levels we will find the quantization intervals. So, this is, let us say, step A, this is, let us say, your step B. Step B is basically given the levels, you will find the quantization intervals, and then we will repeat steps A and B iteratively. So, given the quantization intervals, we will find the optimal quantization levels. Given the quantization levels, we will find the quantization levels. We will iteratively repeat this until we get the final quantizer. So, iteratively repeat these steps A and B until we get the final quantizer. So, the algorithm will be iteratively repeat step until convergence, until none of the levels and the intervals and the levels are not changing. Basically, that is what it means, until convergence to get the optimal quantizer. And what do we mean by the convergence? By convergence, we mean that implies levels comma are not changing, or they are approximately constant. That is, once you observe that with each iteration the levels and intervals, the quantization intervals are not changing, that they are more or less constant, then the algorithm is converged. At that point, you can output the intervals and output the quantization levels and basically determine the optimal quantizer. and use it for the purposes of quantization. Okay. So, that in summary is the Lloyd-Max algorithm, alright, and that is basically a sketch of how the Lloyd-Max algorithm works. Now, what exactly is the working of the Lloyd-Max algorithm? We are going to look at that in the next module. Thank you very much.